Hello and welcome to the video abstract for recombination effects in soft X-ray cluster interactions at the xenon giant resonance, where we introduce and augment our cluster laser interaction model, which is an atomistic quantum classical hybrid model. The irradiation was done at resonance, which predominantly causes xenon to have an inner shell electron ionized. This is later followed by Auger decay, which creates higher charge states. This means that very few ions of xenon are singly ionized when a gas is irradiated. We then look at the cluster signal, and experimentally it was determined that a large 1+ ion signal was detected. This must come from recombination. So recombination was included in our model. We did so and compared our recombination model to plasma models well known and found very good agreement between the two. Incorporating this into one large model for the entire interaction, we simulate in 3 steps the interaction all the way till detected, and recreate full experimental signals. As can be seen in the following figure, the blue curve represents the experimental results, with our results shown in red. The multiple peaks in each charge state are due to xenon's isotope distribution. We find very good agreement, with the big difference being gaps in between our peaks. This is largely due to our inclusion of a single-sized cluster. Multiple sized clusters would be present in the experimental signal. We find also that we can break these signals up and look at a single mass isotope distribution and see what is the cause of each of these ions charge states. So in the following figure we can see, what if we just looked at the isotope distribution for the top 50% of the laser pulse? As shown in blue, we find predominantly the high charge states are created at the peak of the laser pulse, with diminishing amounts in lower charge states. The green, which shows what would happen if we included only the top 90% of the laser pulse, we find that again, we can reproduce most of the high charge states up to around the 7+, but the proportion becomes less and less. And to look for recombination, we look primarily at the singly charged xenon ion. And what we find is the blue and green, while having contributions, the contributions are very small. Predominantly in red, which is the inclusion of all intensities, we see that the difference between the red and green tells us it must be these intensities, the very low intensities, which represent the wings of the spatial distribution of the laser pulse, which do not have a plasma strong enough and so allow recombination. Thank you for your attention.